Right, adding and subtracting standard form. This is the last little bit of our standard form, so after this we will leave it for a while. Okay, let's have a look. I'm going to give you two methods for doing this. One is more straightforward, I suppose, but more prone to mistakes, and the other one's a bit more of a mathematical method, and once you've got that under your belt and mastered it, actually it's a much better method. But I'll give you both. So here we go, we've got two standard form numbers, 6 times by 10 to the power of 5 and 2 times by 10 to the power of 4, and it says in the middle that we want to add them. That's fine. Surely we can just do 6 plus 2. Now the problem is we can't, and I'll show you why we can't, and this is part of method 1. And method 1 is going to be change them to ordinary numbers first. So if I think of this as an ordinary number, well, it's 6, but 5 places bigger. So that's going to be 600,000. Basically, it's 6 with 5 zeros. Yeah? But the 2, it's only 10 to the power of 4, so it's 2, but 4 places bigger. So the 6 and the 2 are in different columns. This is in the 100,000s, the 2 is in the 10,000s, which is why I can't just add them together to start with. But this is my method. This is the straightforward method, right? But you can sometimes make mistakes with this. So you change them both to ordinary numbers first, and then add them together. So I'm going to add my 600,000 and my 20,000 to get 620,000. But then, of course, change it back into standard form afterwards. So it's going to be 6.2 as the decimal, and my decimal point has moved 5 places, or rather my number is 5 places bigger than this. Okay, so you just change them to ordinary numbers, add them together, or indeed subtract if it's a subtract, and then turn it back into standard form afterwards. That's a fairly straightforward method, but it does tend to end up with mistakes sometimes, just if you've changed the number incorrectly. You know, you've got 3 opportunities to make mistakes there. Now, method 2 is actually, like I said, a little bit more mathematical, but a much better method in a way. And this is to adjust one power of 10 so it matches the other one. Because if they've got the same powers of 10, you know, if this 2 is in this column, I could just have added those 2 together. It would have been much easier. So let's think of this again. Now this time I'm going to look at the powers of 10 and I'm going to find the smaller one and I'm going to change it to be the same as the big one. So I've got the 10 to the power of 5 and I've got 10 to the power of 4. So this is the smaller one. And I'm going to adjust it so it matches the other one. So it's now 10 to the power of 5. But it still has to my final number really has to have the same value. Now remember, we do opposites, don't we? So as this number has got bigger, as my power has got 1 bigger, my number gets 1 place smaller. It doesn't go to a 1, it gets 1 place smaller. So it turns into 0.2. So as that gets 1 number bigger, this number, the 2, gets 1 place smaller. They do opposites. Okay. Once I've done that, there are my 2 numbers. I can actually just add together the 2 decimal parts of my number. If I do that, I get 6.2. Now my powers don't change. Notice how over here we ended up with still the power of 10 to the power of 5. I'm not going to suddenly get 10 to the power of 10. It's still 10 to the power of 5. And that's because of that just tells me the place value of my numbers. Okay, so that's the method really in a nutshell. It is to find which power is smaller and adjust that number, that standard form number. So it's no longer in standard form. This isn't in standard form up here, but it does have a power that matches, which means I can then just add together the decimal parts. Okay, right. So less talking, more doing. Let's have a go at this one. Okay, what have we got? We've got 4 times 10 to the power of 5, 2.4 times 10 to the power of 6. There's my 2 powers, 10 to the power of 5, 10 to the power of 6. Look for the smaller one. That's the number we're going to adjust. So 4 times by 10 to the power of 5 originally. I'm going to change it so it matches this one. So it's times by 10 to the power of 6. Now this number has got 1 bigger, which means my number does the opposite. It gets 1 place smaller. So it shifts across to being 0.4 instead. Then I can add together my 2 numbers, my 0.4 times 10 to the power of 6 and my original number of 2.4 also times 10 to the power of 6. Now that they match, oops, that should be a 6, just add the decimal parts together. 2.8 times by 10 to the power of 6, and that is my answer. Yep, let's try it again. Okay, I've got two numbers here, and I've got 6.05 times 10 to the power of 12, and 1.2 times 10 to the power of 10. Okay, this is the one that's smaller, so that's the one I'm going to adjust. So that number is 1.2 times by 10 to the power of 10. I'm going to adjust it so it's now times 10 to the power of 12, so it matches this number here. Now this number, my power, has got 2 bigger, which means my number does the opposite. It gets 2 places smaller, not just 1 place, but 2 places, because this has changed by a value of 2. So 1 place smaller would be 0.12. 2 places smaller is 0.012. It's shifted 2 places. This number is still the same. It's just got a different power of 10. Okay? So 0.012 times by 10 to the power of 12. And I'm going to add that to my other original number, which was 6.05 times by 10 to the power of 12. Now you add the two decimal parts together, which will be 260. Keeping in mind all the place value, 6.062. You see, because the 5 and the 1 were in the same column, so they get added together, times by 10 to the power of 12. Okay, so look at the powers of 10, find the smaller one, and adjust that number so it matches the other power. All right? Okay. I want you to pause the video now and have a go at these two. Now you can use method 1 if you want to, change them into ordinary numbers, add them, change it back, and the answer will still be the same at the end, but I'm going to show you the second method each time in the working out, because I think it's a slightly more mathematical method, okay? Right, so pause the video and have a go. We have unpaused the video. So look at the powers of 10. I've got 10 to the power of 7, 10 to the power of 6. This is the smaller one, so that's the one I want to adjust. 1.8 times by 10 to the power of 6, and I'm going to adjust it so it now matches the other one, which is 10 to the power of 7. Now, this number, my 6, has got 1 bigger, hasn't it? 6 to 7, which means this number does the opposite. It gets 1 smaller. As one gets bigger, the other gets smaller. So 0.18 times by 10 to the power of 7. Both sides of this are equal. It's just going to be easier to add them together now. So 0.18 times by 10 to the power of 7. And my other number, which was 3, also times by 10 to the power of 7. Because those powers match, I can just add my decimal bits. 3.18, and it's still times 10 to the power of 7. Okay, and even if you use method 1, that should still work. 3.18 times 10 to the power of 7. Okay, my other powers, 10 to the power of 6, 10 to the power of 4. This is a smaller one, so that's the one I want to adjust. 3.05 times by 10 to the power of 4. And I want it to match my other number, which has 10 to the power of 6. So I'm just going to adjust my number here. Okay, this has got 2 bigger. From 4 to 6 is 2. So this number, the decimal bit, has to do the opposite and get 2 smaller. That's 2 bigger. This one gets 2 places smaller. So 2 places smaller, it's going to become 0.305, and then another place smaller to become 0.0305. Okay, right, and then we can add them. Now they've got matching powers of 10. We can just add those two numbers together. So that's 0.0305 times 10 to the power of 6. My other number was 2.18 times by 10 to the power of 6. Now I know some people, when they're adding numbers like this, adding decimals, they like to fill in with some placeholders, so we could do a bit of that to make it a bit easier. Now we know that the 10 to the power of 6 is going to stay the same, so let's add these two numbers. 5 and 0 is 5, 0 and 0 is 0, 3 and 8 is 11, so I'm just going to carry the 1 over. 0 and 1 is 1, but add that 1 as well to get 2, and 0 and 2 is 2. 2.2105 times 10 to the power of 6. Should I just make it a bit clearer over here, because that was a bit scrappy, wasn't it? 2.2105 times by 10 to the power of 6, yeah? Good. Right. Okay. What have we got for you next? Now this time, we got another problem. But I want you to have a go at this on your own. See if you can adapt our method to work for this. Because look, now we've got a minus. I haven't got an add, I've got a subtract here instead. So see if you can adapt what we're doing. Really, have a go. Even if you get it wrong, it doesn't matter. Just see, have a go, and then see if it matches my answer at the end. Okay, so pause the video now. We have unpaused, so let's have a little look. Now to start with, we're going to do the same thing. 10 to the power of 7, 10 to the power of 6. So this is the smaller one, so that's the one I'm going to adjust. 5.7 times by 10 to the power of 6. I want to adjust it so it matches the other power of 10, which, look, is 10 to the power of 7. Now, this has got one bigger, hasn't it? 6 to 7 is one bigger, so my number gets one place smaller, 0.57. So 0.57. Now, this is the important bit. We're doing the first number, take away the second, so I must write that. I must do 3 times by 10 to the power of 7, take away my other number, which is now 0.57 times by 10 to the power of 7. Now, subtracting does make it a little bit trickier, and certainly at this point, I would suggest putting in some placeholders just to make it a bit clearer to see what we're doing. So I'm going to do 3 take away 0.57. Well, 0 take away 7 I can't really do. I've got to borrow all the way from over here. So that becomes 2. Borrow 1 to make it 10. I'm going to borrow from that to make that 9. Put 1 over there to make 10. So 10 take away 7 is 3. 9 take away 5 is 4. And 2 take away nothing is 2. So 2.43 times by 10, and the powers stay the same, 10 to the power of 7. And even if you use method 1 for this, turn them into ordinary numbers, subtract, change it back, you should still get the same answer. Okay? Still confused? Hopefully not, but you might be. Who knows? Let's give it another go. This one, 10 to the power of 6, 10 to the power of 5. This is the smaller power, so that's the number I'm going to adjust. 2.91 times by 10 to the power of 5. I want it to match the other power, so 10 to the power of 6. So we're going to adjust our number here. That's a 10. Now the 5 to 6, that's got one bigger, which means my number does the opposite. It gets one place smaller. So 0.291 times by 10 to the power of 6. Now remember, we're doing the first number, subtract the second number. So we write the first number, 3.6 times 10 to the power of 6, subtract the second number, 0. Keep the place value, keep it in the right place there, 91 times by 10 to the power of 6. Right, now I've got a couple of extra decimals there, so I'm going to put a couple of placeholders in. 0 take away 1 I can't do, so I've got to borrow all the way from over here. So I'm going to borrow there to make, change that to a 5, take 1 across to make 10. Now I'm going to borrow from that, so that becomes a 9, and this one in here becomes a 10. I hope you can read that. So 10, take away the 1, leaves 9. 9 is in this place, take away the 9, leaves nothing. 5, take away 2, leaves 3, and 3, take away 0, leaves 3. 3.309 times by 10 to the power of 6. Sorry about the small writing there, but it does work out, I promise. 3.309 times 10 to the power of 6 is right. Okay, so it's the same method. The only difference is, remember to do the first number, take away the second number. Yeah? Right, it's worksheet time. Online worksheet, so it marks it for yourself. You've done these before, so you know what's going on. Once you've done them, you press check answers and it'll check them. If you need a new worksheet, click on new worksheet. Otherwise, you adjust your numbers, add them together, put your answer in here. And it says to give your answers as ordinary numbers, which I've just read, which is really annoying. But it was the only worksheet we could find for this. But it's still really good practice. Let me do the first one with you just to check that you're happy with what you've got to do. Now we've got two powers of 10, 10 to the power of 2, 10 to the power of 3. So this is the smaller one, so that's the one I'm going to adjust. So 2.5 times by 10 to the power of 2. I'm going to adjust it so it matches the other one. So it needs to be 3. Now my number has got one bigger, the power has got one bigger, so this number gets one smaller. So 0.25. I'm then going to add the two numbers together. So I'm going to add, because it says add on my question here, so I'm going to add them together. 0.25, and I've got 6.5. Let's put the extra 0 in just to hold the place there. Add them together. So 6.5 times 10 to the power of 3. Now we know that means that it's this digit, but 3 places bigger. So instead of 6.75, it gets 3 places bigger. So that would be 1 place bigger, 2 places bigger, 3 places bigger. So I would write in here, 6750. So it does want you get a little bit of extra practice here, changing it back into ordinary numbers at the end. Okay. Now the link is in Show My Homework, or if you've lost it, you can always type down that tiny URL and it should work. Okay. So good luck with that.